Sweet, another day. So the computer work is basically done. I got to finish some of the mail out stuff today, and I got to take some better pictures. But to get some better pictures, I need one of the pens done with a new style grip that I'm working on. And to do that, I need to machine it. So that's what we're going to get into now. Before we get to machining, I have to clean this mill out. The flood oil system, or the mist oil system, I should say, works decently well. It just makes a crazy mess, which is one of the reasons I want to flip over to the flood oil system. I just have to finish building the actual enclosure. This is still the temporary enclosure, but that's a story for another day. The one thing I did do to all my machines that I'm very happy with is network them. So they're all wirelessly networked to my main CAD computer, and I can ship them code and pull code off them. So here I'm just pulling off some of the old grip code to modify it, run some more variables so I can select grip options with variables at the start of the code. So I'm not opening and closing so much G code all the time. But yeah, I'm quite pleased with how this worked out. The dual tailstock support goes in place. It registers against a little stop on the side of the vise. I tap into place, and then I noticed the vise wasn't quite clamped correctly, so clamp it correctly, tap it in place, and then torque it to spec. That way everything flexes the same amount, so when I repeat pen after pen after pen, it deflects the same amount, if there's any deflection. These little machinist vices don't really deflect at all. I then tap the back end of the pen tight against the support, and then I tighten the little screw, and that just basically tensions everything, provides good solid support. I eyeball down the side of the pen because I want to clock the grips to the bolt action, so I just make sure that I'm close enough there and I can tweak it left and right if I need to, and then we run the code. So now the machine's just going to go back and forth and start cutting the flute grip, and once it's finished with one grip, it's going to index to the next one. There's a few ways I could do this. There's actually much smarter ways that I could be cutting this grip instead of using such a sharp point cutter. But I use the same cutter to also cut the ring grips, which you'll see coming up shortly here. So it's a walk away procedure, and that's more important to me right now. Here you can see an error in my code. There's a spindle stop that I didn't quite catch, so thankfully I was just watching it. This is the first time I'm proving out the code, or this modified code, so I keep a close eye on it. Anyways, stopped it, adjusted it, made sure the spindle start code was still in there, and carried on through with it. This is going to run all the ring grips now, so the fourth axis is just going to spin through 360 degrees, and the little sharp point tool there is going to cut all the grooves nicely spaced. Once again, this isn't the fastest system on this machine. This would be way faster to do on the lathe, but I could just load a pen in and walk away, and that's far more important to me than cycle time right now. It's just walk away time. This is the grip directly after machining, and then we're going to give it a light Scotch-Brite. That helps to remove all the kind of gunk in the grooves, but it also makes sure that it's really smooth. Since your fingers are going to be interacting with this grip all the time, I want to take off any kind of sharp edges. The outside of the pen still hasn't been finished here, but at least it's smooth and the grips aren't going to, create little hot spots. I get a few questions on the fourth axis setup I have for my machine here. So what I'm currently using is, this is the MicroArc fourth axis by Tormach, and it fits on a Grizzly G0704 pretty good. This is a short bed version. Most of the G0704s are long bed, but the ones I sell in my neck of the woods are just short bed, but it works well for my purposes. I set this up so it just clears my two little toolmaker's vices here, and then I clamp that one fixture that you saw in the previous images just to do tailstock end support on all the pens. Works out decently well. I'd like to find a better way so I don't have to remove the support every time I swap a pen in, but it's repeatable, it repeats stupid well, and this thing is definitely accurate. On those pens, when I machine the frag grips, I actually come from 360 to 0 and then back to 360. I have no overlap, and even under the microscope I can't see, there's no discernible lash. So these are very accurate units. I'm super happy with it. Not cheap, but very accurate. In the past I had used this, which actually worked out decently well. It just has a ton more lash. So this is just a generic rotary fourth axis that I coupled a stepper motor to with an old plate that just old aluminum plate sticking out and a belt drive, and then what I did is I shimmed the worm gear, because these are driven by a worm gear that runs against a spur gear or a mating worm gear drive piece inside here, and they typically have a lot of lash, but this one you can adjust the worm gear in and out, and I adjusted as tight running as I can, but still after every month or so I'd always have to adjust it to get the lash out of it, because you can probably hear it. I'm not be able to see it. Maybe if I zoom in close enough. Let's use the old Zoomatron. There's a significant amount of lash in the gearbox here, so I had to be really careful with the way I set up toolpath so I'd always be functioning one way. But it worked. I made a lot of pens with a lot of grips and a lot of bolt action slots with this. You just had to be very careful on how the code ran. Whereas this one, I can run any which way because it's rock solid. It runs on a harmonic drive inside, various forms of it, but it's a strain wave gear, I believe is what this one uses.
And yeah, there's zero lash, or nothing detectable anyways by outside methods. And when I'm machining with it, since everything is so tight here on this table, I take this big collet nut off, and I just put this cover on, and that gains me just a little bit of extra wiggle room on these vices, because I don't have a lot of real estate here. But like I said, for my purposes, works out really, really well. So when I upgraded this machine, I'll hopefully put some better footage in here. The fixture plate that I have on it, I put it back in place, and then I machined it, or I remachined it in place. I rebored all the fixturing holes. That way I knew everything is exactly in line to the machine, and I actually did it with the CAD model. So I know that the CAD model on this machine is exactly the same that's on my computer. So when I design things, for instance, I know exactly where these vices are digitally, so I can model all my code before even running it, even if this is running a job. So that's saved a ton of time. I'm really happy with that. Actually, what I did do is I have more machinable area here where I was going to build a wine rack tool changer, so I could further automate this. But honestly, this little mill, despite how small and relatively slow it is, isn't really my bottleneck. My bottleneck is just lathe parts. So that's the next thing I'm really focusing on, is just trying to speed up processes through that. It's a deathly accurate machine, but there's still a lot of operations I do on it. So we'll see what the future holds. And yet again, Mr. Clock tells me that I have ran out of time. So that's where we're going to leave you for today. I will carry on with you. I think Thursday is the next episode. And until then, have a fantastic day. I'll see you guys later. Take care. Bye-bye.